All right, so my plan for RIP is that I'm intending on covering it in 3 parts. We're going to start with, in this video, covering RIP basics, and then we will switch over in the second video to talking about how distance vector works, and then in the third video we will look at some of the challenges that RIP faces and the solutions we have to dealing with those challenges. So let's take a look at the RIP basics to begin with. So as you'll recall, RIP is one of our dynamic routing protocols that we can employ in a local area network. And it employs a method called distance vector. For determining the best route to send packets in order to reach a destination. This is what we would refer to as a distributed protocol, as RIP is run on all of the routers in the network. Each router is going to maintain a table that contains information on how to get to other networks. This is a lot like our forwarding tables that we've talked about in terms of static routing. The difference is that this one can be updated with new information. Each router is also going to have what we call a distance vector, going again back to the name of the method of how we implement RIP. This distance vector is what it advertises to other routers. And specifically, we advertise only to our neighbors. We don't pass this further on because it can lead to some major problems. So we only advertise this distance vector to our immediate neighbors. The contents of this distance vector are who you can reach, the cost to get there, and in an actual implementation, this isn't in the original distance vector algorithm, so it's not in, this is an actual algorithm. In the original distance vector algorithm, it doesn't have this, but in ours, it is going to have basically a next hop as well. Remembering that this next hop is the local IP that you're going to go to. At the start of running the protocol, we have some basic assumptions. Cost of direct links are known. So if I have some router A, let's say it's connected to B and C, A at start will know the cost of this. These can be arbitrary. These can be set up based on some sort of metric. We right now are just going to basically assume that each cost is basically just a hop cost for us. We also assume that we know, let's say not we, let's say A will know about its directly connected neighbors. It can't see anything further than C and B at the start because the protocol has just started. Nobody has been sharing any information. If there were other networks that for some reason A knew about but did not have an immediate connection to at the start, we would say that those other routers or other networks would be at a distance of cost infinity. This is basically our way of saying these are unreachable. So if there was another router out here, there was a, say, router D, A would know the cost to get to B would be a cost of one hop. The cost to get to C would be one hop. But the cost to try and get to D, if for some reason A knew about D, we would say that that would be infinity for A to reach D. And this is only at the start. This might change as the protocol runs. So as the protocol starts running, B is going to eventually advertise to A that it can reach D. So B will eventually advertise to A that D is reachable, but at the start, A doesn't know that. Now, infinity could be assigned again. Let's say protocol's been running for a while. If for some reason a router or a network loses connection, eventually what will happen is that information will be passed around enough to the network to where that entry in the distance vector will change to one of infinity. If that connection is restored, then the distance vector could change it again. This network is maintained by two different types of updates. We can have periodic updates and triggered. Periodic updates are a basic heartbeat type system. Basically saying, I'm alive. Triggered updates are what would happen, let's say, if a router was disconnected. That would trigger an update. Periodic updates have a time. These can happen randomly. And by randomly, I mean whenever that adding or removing of a router has been triggered. And so now what we'll do is, this is pretty much all the basic information you need to know about how RIP works fundamentally. In the next video, I will take a look at how distance vector works.